Now, what do you want me to do?
I'm going to ask you some questions.
Okay, you ask me the question.
I think you're ready.
Am I supposed to smile?
Oh, yeah.
Well, you know, that was the thing about Rossi. He has such a nice smile.
Tell me about the material you cut your dies on. What type of material is this?
Well, this is the boilerplate that I was able to purchase from the Cooper Bessemer, and they would have this different thicknesses of steel that you could that they would use to make what they would call weldments. So they had a supply of steel, and I would go and buy this piece of steel, which is a soft steel, and I could cut the dies on it. It would be satisfactory for using aluminum, to hammer aluminum on. And it was it was soft enough that you could cut it. There was a problem about it in that if the piece of steel wasn't thick enough and you hammered on it for a long time, even though you're hammering on aluminum, this would bow up a little bit. It was very important for the steel to be flat on the back side, because when you put it on the table, you hammered on it and it wasn't level or flat and tight to the table, why you would have it would be dead. And
What do you mean be dead?
well, it means that your hammer wouldn't bounce. It would have to spring down until it hit the table, or it would well, it just wouldn't bounce, and it would tire mine out. That's why an anvil is good, because it's heavy and it will you can hammer it on it and it resists. It's heavy enough to resist, so you have to have a resistance.
If that would happen, could you fix the die? Could you
Well,
grind
you'd
off
have
the
to
back?
take it and grind off the back. You had to grind off the back and put it in a lather on a grinder and grind the back so that the back would be flat. Oh. So you had to have the back of it. This was, you can see that has been put in a lathe, and it is
And ground down.
it is flattened out. You put it in a lathe and make it so that it's flat. Now, if you have a low place, that it'll bridge over it. But
And what's
you
this?
see, if you put it on a grinder, sometimes you put on a magnetic chuck grinder, and the chuck grinder will pull this into a and make it flat, and then you grind it down. Then the magnetic chuck lets loose. Why, it'll still be hollow. So
You had a. I see down here you have a device. This is what is this?
well, that's a turntable, so that when you cut it, you can swing your die.
Different positions.
Yeah, to get it.
All right, now, now the type of material you'll put the die on, you've described. It held up satisfactory for using aluminum. Would it hold up all right for any other material?
No, because one of the characteristics of all metal is when you work it, and hitting it would be one of the ways you work it. The metal work hardens, and the metal gets hard. As soon as you hammer it, it gets hard all the time.
Which metal? This?
No,
or
the aluminum. Or if you were using copper work hardens and silver work hardens, and the way that you have to work those materials, if you're like making a bowl or something, is you work the metal until it gets work hardened, and then you put it in you heat it until it comes up to, well, the correct temperature, and that
Does it make it softer again, or does it make
yeah, it anneals it. So
you didn't have to worry about those kind of things because
you don't have to do it on aluminum because you don't, the work hardening doesn't hurt it any. It only makes it better. You start with a very soft aluminum and you work it, it gets harder, but it doesn't get so hard that you have to anneal it.
And then you worked exclusively in aluminum.
I work exclusively in aluminum, and this die would not be good for another metal. Now, one time I wanted to try it, and I got a piece of copper and I hammered it into a ship die that I had. And when I was done, I had hammer marks in this die. So I had to recut the die. And the piece of, well,
with the aluminum though, how long, how many years, or how many times could you make a piece off of it?
innumerable time, but the problem is cleaning, and you build up an oxide when you hammer a piece of metal, the aluminum stretches, and when it stretches, it makes at the edge of the hammer mark, it moves on the metal, on the steel, and deposits a little bit of aluminum oxide. We call it a blue mark, because if you don't take that off, it will appear on the next one, and it also appears on the aluminum in the first place. You have a part of the blue mark on the aluminum and part of it on the die, and if you don't take it off the die, then you'll just accumulate blue marks on your piece. Now the aluminum oxide is hard.
How did you take the blue marks off the die? How do you do that?
You have to take it off with an abrasive.
Like what?
Like this. It was a fine abrasive. Well, if you use the fine abrasive, you destroy your die if you hit the edge of it. So what you need to preserve and to keep a die in good condition is the edge of the die, because when you
like the sharp corners or
the corner, which is what when you put the color on the last, that's what keeps the color in, and it also gives sharpness and definition to the die, to the pattern.
Let's go back then to the actual cutting the die. First of all, you had to have some design, and after you came up with a design, how did you get it onto the metal so that you could cut the die? Did you do it freehand, or did you draw it on the metal?
No, you put it on. You transferred it by carbon paper, and the first thing that you would do would be put on the die, on the metal, some kind of a coloring agent.
What would be the agent be?
You could use a copper sulfate, which would make a copper sulfate dissolved in water would leave a copper color on it. Now you could also
would that be something you could mark through or draw on?
Draw on so that your carbon paper, your line would show up on the. And so you had.
How did you put it on in reverse though? A die has to be in reverse. And so did you...
Well, you have to make your drawing, and then you have to reverse the drawing.
How would you get the drawing reversed?
Well...
Did you do it on tracing paper and turn it upside down, or...?
Yes, you can put it upside down, or you could use...
Just draw it in reverse.
Oh, no, you don't draw in reverse. But you can... if you have ever used carbon paper, you might get your carbon end upside down and find the carbon on the back of the thing you were drawing. Well, if you put down two pieces of paper and you put your carbon upside down on under the second one, and then you trace.
Turn it back over and then you trace around it.
Well, if you trace over, you'll you'll have the pattern in reverse on your second sheet, or on the back. If you don't have a second sheet, you'd have it on the back, and then you turn it over and draw it up. Put the
But then would you scribe through it so you could make a mark on the metal?
no.
How would you get it right onto the metal so you could use your tools to
use
cut?
tracing part of paper.
Okay.
Tracing
Put another piece of tracing paper down and do it.
Yes, that's right. You
What
do.
type of tools did you use to cut this down?
Well, I have these various tools.
What are they made out?
Well, they're made out of tool steel.
Tool steel? What's tool steel?
Oh, that's hardened steel, like any.
Did you have these tools made to your specifications? Did you make the tools?
No, I had. There was a tool company in town at the time called. Well, they have the designation on the RBT. Do you remember that, Roy? Did you ever see RBT? Do you know what RBT stands for? Rainey Brothers Tool.
Rainey Brothers Tool.
Yeah. Old Clyde Rainey was he would forge these out, and because they were a lot smaller than normally what they would make.
Did he make them especially for you?
Yeah, it made them special for me. Although you have this is a gouge.
What's this one?
Well, this would be a chisel, and this is the diamond point, because the cutting edge is on the diamond points. Then of course I would work these in myself and work and grind them, because when I wanted to make a very small line, a point on a chisel wouldn't hold up under the pressure, and so I would actually be making a very small chisel on the point of this tool, and I think you would have to get closer to see this, but you see. So actually,
I just thought I'd give you a chance.
and then these tools, when you want to go around a corner, you have to have clearance, so you would grind the tool so that it would be smaller behind the cutting edge, instead of being bigger behind the cutting edge as it would normally be. You had to grind it down so it was smaller behind the cutting edge, so when you would turn it like this, you can't turn it if you get in a groove. You're cutting a groove, you can't turn it
Unless it's smaller behind.
unless it's smaller behind.
So
So that's the reason.
really what was happening, you had him make the tool that was hard, and then you continued to
Yeah, then
shape the
then you
tool
work on it
for
afterwards.
your needs as you used it up.
That's right.
And how then do you actually cut the die? How would you do it?
Well, you just start out and well, I would normally start out with a tool that would make an edge like this if I wanted it round, or if you had an edge that was sharp, I would cut it with a square cornered tool or a round cornered tool. But most of my things,
Show me how you would do it. You needed a little magnification.
well, as you got older, you needed more magnification, because one of the characteristics of concentrating and you're using both eyes, and you're getting down like this, you're working cross-eyed all the time, because your eyes are crossed, because they're focused at a short range. Well, if you put a loop on, which I don't know what power they have. These are different powers. These glasses are different powers. I think this is, I don't know whether it's 10, I don't, didn't,
Well, show me how you would do it.
well, you have to get in focus, and of course you have to get in focus, and you have to have room for your hands underneath the thing, so.
So it really doesn't take much pressure to cut through the metal with a sharp tool and the
If
hammer.
your tool is good and sharp, the biggest problem is to keep the tool biting into the metal and not sliding along the top. So I'm putting a lot of down pressure on the tool to make it bite into. Well, if you have a I don't know, something like I don't know whether I lend some of the tools to. Oh, here's one. See, now here's a chisel that I've cut cleared behind to make it smaller than the point. And if you'd go and make a, then you'd come this way to. And you could now this was it. Every chisel mark you make in the die appears on your final work, and it is and the chisel marks are important because they give character to the work. And
Why did you make,
if you had some mechanical way of cutting this metal, it would have a tool. It would have a tooled effect. But when you have a
in other words, the die reflects the tools that you use. If you
Yeah,
use
but
a
that's
mechanical
right.
means,
yeah, actually the die is has hammer marks. Has tool marks in it. So it has character. The bottom of the die has character, just like the hammered material outside, and it all has the right character. But if you would keep cleaning this die, you would lose the character if you
Yeah.
got your abrasive in there. So if you had a hardened die, and I should have gone to hardened dies, then the dies would have kept in original condition.
a hardened die would be one that after you cut it, then you made it hard.
Yeah,
Did you have to use different kind of metal to do that, or steel?
yeah, you have to have a tool steel to begin with. Instead of buying soft steel, you have you buy tool steel.
Did you ever consider doing that?
No, because I never considered, well, not too seriously, because
How often, if you didn't do it, how often would you say touch up a die, just like you're doing here now?
well, it depends on the workman, how careful he is when he's repoussing, and if he takes off the blue marks and he goes with his sandpaper and hits this edge, well then you destroy the die, so you have to just come up to the edge all the time. And everything is worked as far as abrasive and cleaning is, you think of the finishing, and the finishing is all done in a certain direction. All the finishing is done in the horizontal
Direction.
direction. That's right, the horizontal direction.
The depth of the die. What was your concepts of how deep a die should be?
When I was making the original trays, there was an attempt to, on my part, to keep the dies as shallow as possible and get definition. Because if you were going to use the tray to set glasses on or anything, you didn't want them things to rock. So when you were done, you wanted to have a fairly flat surface. As things developed, and instead of making serving pieces, you made pieces for decoration to hang on the wall, or ashtrays and things like that. It doesn't make any difference how deep it was. And so, especially when you've gone into another metal which wasn't compatible with food. Aluminum's compatible with food. Copper and bronze are not compatible with food.
So you wouldn't want to use them for serving.
Well, you have to lacquer them to keep them from oxidizing and getting dark.
But your focus throughout
Aluminum, you don't have to.
your focus during your times of production was related to serving trays. It was not necessarily decorative pieces. You were
They were decorative, but they weren't decorative only.
double surfaces.
And so the dies, I tried to keep them shallow, but you see, you have to have to get definition inside the pattern, you have to have different depths. And especially now here, this trunk is in front of the one behind it, so one has to be deeper than the other when it's crossing.
Once you have, working on a die, how would you tell that it was coming the way you wanted it? Would you take a little sample, or what would you do?
Yeah, you can take a sample anytime you want, or you get me a piece of metal here.
That would be better. You can tell how it came out.
Yeah, you can tell the new chisel marks that I just put in there from the old ones, because they're a little different in color.
So you can just take a little sample as you go along and see how you're
You
doing
can take
it.
samples if you're in doubt. You can learn to read them, and you learn to read and think upside down, because it's all not only reversed as far as
Now this
the
die,
pattern is
this die
concerned.
has a border around it. Why did you elect to put a border around some of your dies?
because all the patterns I made to fit certain pieces of the furnished work. And this I made for a tray that would be about 1.25 inches bigger than this. And I to make a finished piece, it's better to have a border. It's more decorative for aesthetic reasons. Now in this particular piece, I use this part of the die, this one tree, to make a square server or a round plate. And if I do that, I would have to cut out the border. By cutting out the border, you
Just
don't
don't
hammer on the
hammer on
border.
All right.
Now, if you want to hand that piece of cardboard right there,
This one?
yeah. No.
Maybe it's this one.
Cut out some. we would bake this. And that's shows you what you should repoussé to miss where the border is. So when you would put this on the piece of aluminum, which was 12 inches square, put it on, and with a pencil you would mark around here and on the back, on the back, so then that you would have to repoussé, hammer, and not come onto the mark, because if you came, you'd get a piece of the border there.
Okay, so you could modify the what you took off of your larger die, make a smaller section of it.
That's what we did. Now, it would, from a production angle, you ought to not have the border. It would just be much easier to not have the border, but if you wanted to use a part of the die, you had to have patterns. In fact, you had these patterns to mark on the aluminum, so you'd know where to hammer. But this is what, and it would be an advantage from a production angle to not have the border on.
How long would it take you to make a die like this one? How long?
Well, I would say about, well, in the first place, you have to get the metal prepared, and it has to be perfectly smooth. Not consider, after you have the metal prepared, and you would have the drawing made, and you transferred it on there, then I would say it would take about 3 days to do this.
Of working, just
Constant
constantly
work.
working.
Yeah. But,
Then the die would last, this lasted for 50 years
yeah.
with proper care and proper use.
Yeah, if you give it the right care. One of the things that you have to fight is rust, because rust will tip the aluminum, and there's places here that this is
How do you
pitted.
protect it from rusting?
Well, you have to oil it.
In other words, when you're not using it, you'd put oil on it.
Yeah, you have to oil it. But they have a tendency to attack condensation, and if they attack condensation, then you'd have to work out.
During the course of your business, how many dies did you make?
Well, counting large and small ones, I would say that probably have 60, 65 or something like that, because you have small ones, you can see there's small ones. No, up above there.
Like that.
Yeah.
These would be specialty type.
That'd be specialty.
You made designs
The rotary
that
plow.
you wanted to do, and then you also did make some designs for particular
Yeah.
organizations
Yeah.
if they wanted an
Special
extra
orders.
special order type of thing.
Now, let's see, what's that, there's a lettering on there. What's the lettering on there say, Tom?
This one was for.
Can't you read it backwards?
That's a Masonic order
Yeah.
constituted hermitage.
Here, let me read it.
You can read backwards.
I'm used to thinking backwards. This is Hermitage Lodge, number 810.
78.
1978, May, I don't know, something there I don't. It's April 7th, 1978. Hermitage Lodge number so it was constituted in April 7th, 1978.
This is a list of patterns that you had. which one of the patterns did you like the best?
Well, you listen. It's like asking which one of your children you like the best. You don't say that exactly, but you can't make a die angry. So I can say that. So I take that son. Because if you lay that piece of steel on here, you're liable to make a dent in it, and then you have to take it out. And the way you can take it out, and I think this is a little interesting, is that the back has to be flat, but the front doesn't have to be so flat. And if you have a scar on this pattern, you can take it out by with abrasives, and you might have a dent in the top, which doesn't show when you hammer it, because the hammer marks are all like that anyway.
It just kind of blends in.
It blends in, so you can repair the front. Sometimes even I would hammer it with hammer the steel with a flat hammer and forge the
pits or something out of it.
you could forge something out of it.
Okay.
But if you have it smooth, why then the surface under the aluminum has to be smooth. The back has to be straight.
Okay, we're going to stop there.
Shape on there would just be ideal for making it along like this. So you'd go along like this, and you could practically make the limb in one cut. Now, when it got to be about that size, I think I have another tool that's almost the same as these.
Not cold.
Now, like this, you take a round and make the first cut with this, and then you'd go along with, well, I guess there's even a wider tool, and the wider tool would go along, and you'd take this one side off, and so you had an edge up there that was round, but down here you worked it into
And it's tapered it in.
tapered it
Yeah.
in, and see, that tool was cutting that far there, and you get a tool mark that shows up down in here. You'd use
Maybe something like this.
here, this is the one. Now that would give texture. I was never one to make much texture. When Natal, for instance, would take something, he'd have a tool that he could just make texture with, and I had some tools in here like this that I would make a die. I'll do this over in the edge. This way. I'll have to have a heavier hammer.
Yeah. Well,
But,
the idea is you could make it by pounding on it.
Well, this was a die that I made with grain. So that would be the center of the grain, and then this was one that I made for snowflakes. But you could make a die by driving it in, but this
Or
is,
cutting or driving it in or just
yeah,
whatever.
driving it in. But if you drove it in, then you had a tendency to, well, you always have, if you drive something into the metal, you put a ridge on the outside, then you have to smooth it off because